learning pleasures. All right, so today I'm going to show you how to solve one-step multiplication, division equations. Now, we learned how to solve addition and subtraction equations. Today we're going to solve multiplication and division. It should be easier. All right, are we all ready? Ready or not? Here we go. Okay, so if I have the problem 5x is equal to 30, okay? 5x is equal to 30. Now, again, your goal in life right now is to get x by itself, right? So what's the number that is next to the x? The 5, right? So I want to move the 5. So I want to move the 5 to the other side. So what I do is I draw the bars, right? And I have to move the 5. Now, the thing is, do I add 5? Do I subtract 5? Do I multiply by 5? Or do I divide by 5? How do I move the 5 to this side? Well, you have to do the opposite operation. If the 5 is right next to the x, and you zoom in right there, do you see an addition sign? No. Do you see a subtraction sign?
No.
Do you see a division sign?
No.
Do you see a multiplication sign?
No.
Gosh, there's nothing there. So, ladies and gentlemen, when there is nothing there, even though I zoomed it in real close, gosh, I don't see a plus, minus, multiplication, division sign. What's there that you don't see that is super, super small, microscopic, is a little dot for multiplication. Meaning, when the numbers are squished together, that means multiplication, okay? That means multiply. That means multiply. So the opposite of multiplication is to divide. So this is how I show my work. I'm going to put the fraction bar and then the 5 underneath. So when I put this fraction bar, that means division. So I'm dividing by 5, dividing by 5. So I'm going to draw my line. So when I divide 5 divided by 5 on this side, I'm just left with an x, because 5 divided by 5 is 1. So I'm just left with 1x, or we just write x. Now on this side, we do the math. So 30 divided by 5, what is 30 divided by 5?
6.
6, thank you. So that means that x is equal to 6. So again, when you see a number right next to a variable like this, it means multiplication. It could be a different variable, like 7y. When they're next to each other like this, it means to multiply. So what are you going to do? You're going to divide. Okay, it might be a negative number, like negative 2w. But when they're right next to each other, this all means multiplication. And when we try to solve it, we need to divide because we have to do the opposite. Okay, so let's try another problem very similar to this one. 4m is equal to 32. Okay, write this down. Everybody's writing this down. So your goal is to get m by itself, the variable all by itself. So I'm going to draw my bars. So if it says 4m next to each other and you zoom in and there's no plus sign, there's no minus sign, there's no division, there's really no multiplication sign either. What is there that you don't see is that indeed it's being multiplied. You just don't see the dot. They save their ink. So the opposite would be to divide. Now, how do we show division when we're solving equations? We draw the fraction bar. This fraction bar means division. So we're going to put a 4 underneath and a 4 underneath. So this way, this gets eliminated. We no longer have it. We're just left with m all by itself. You guys see how it's m all by itself? And on this side, we do the math. What's 32 divided by 4? 8. So m is equal to 8. Are there any questions so far? So this is solving multiplication equations. One step and you're done. Now we're going to move on to equations that involve division. For example, let's do x divided by 5 equals 10. Now, a lot of my students will say, the answer's 2, Miss Lomelli. The answer's 2. And I go, uh-oh, you didn't show your work correctly. So, what does this line mean in math? What operation is this line? Division. So that means I'm taking the variable and I'm dividing by 5. So what's the opposite of division? Multiplication. So that means, yes, very good. So that means in order to get x by itself, got to move the 5. How do I move it? I have to multiply by 5, and I have to multiply by 5 on this side. Whoopsie. So this, when I do this parentheses and I put the 5 under inside, that means I'm multiplying, okay? So this is the type of work I want to see when I check your work later, okay? So this gets eliminated. It actually gives me a 1, and I'm left with x all by itself. And on this side, I get to do the math. What's 10 times 5? 50. So our answer is 50, not 2. So when I plug it in, let me check. If I go 50 divided by 5, what is 50 divided by 5? 10. Hey, that's what I'm supposed to get, right? It checks out. If you told me the original answer was 2, is 2 divided by 5 10? No, right? It doesn't work. So some of my students will take, oh, I just have to divide this by 5. I'm done. Nope, because this, no bueno, doesn't work. All right, let's try another one. X over 7 equals 3. X over 7 equals 3. So when I say over, it means to divide, right? So here's a division problem. So I'm going to draw my bars. Instead of dividing by 7, what are we going to write down to show our work so we get full credit for this?
Times 7.
Times 7 on this side, and you have to do it on both sides. And when I check your work, I'm going to be checking that you wrote the 7 twice, and then you wrote that you're going to multiply. How do you write that you're going to multiply? You put parentheses. So this gets eliminated. We're left with x equals, what's 3 times 7? 21. Okay? So when it's written as division, when it looks like a fraction, that means it's being divided. Okay, when it looks like just like this is like a fraction, but in reality, this fraction bar has always been a division bar. Even when you first started learning about fractions, this line was actually a division line. Just no one ever told you. They kept a secret from you. All right, let's just recap from the very beginning of time. If it's x plus 2 equals 7, what am I going to do? How do I get x by itself? Let's do a quick little review. What do I do?
Minus 2 on both sides. Put the 2 on the 7.
Okay, so if I do that, am I going to get full credit?
Maybe.
No, you're not. What are you doing to the 2?
You're subtracting it?
Subtracting it.
Put a negative.
No, not a negative. That's not a verb. Subtraction is a verb. So we're going to subtract 2, and you're going to subtract 2. If you do it at both sides, and if you tell me the operation, you get full credit. If you just write the 2 without telling me what you're doing with it, you won't get full credit. So this is perfect showing my work. I'm going to subtract 2, subtract 2. Here I get 0. Woohoo! Just going to write x equals. Here I do the math. 7 minus 2? 5. I'm done. Now, what if it's x minus 2 equals 7?
We do plus 2 on both sides.
Plus 2 on both sides, plus 2 on both sides. Notice here, it's the opposite operation, right? Opposite operation. So I'm left here with an x equals, what's 7 plus 2?
9.
9. So take a moment. What's the difference between these two problems? What's the same, right? I get completely different answers, right? So in subtraction, in addition, you're going to subtract. If it's subtraction, you're going to add, right? All right, what if it's, let's say, 2x equals 4. Now what do I do? 2x equals 4. How do I move the 2?
You divide by 2 on both sides.
Divide by 2 on both sides. Excellent. So what is x equal to?
2.
2. Exactly. But what if it's written, watch it, watch it. What if it's written x divided by 2 equals 4? Should I get the same answer?
Multiply by 2 on both sides.
Multiply by 2 on both sides. Very good. This gets canceled out. It equals 1. So we go x equals, what's 4 times 2?
8.
8. And that concludes our review session. So here are the 4 different types of ways to solve an equation depending on if you're at the beginning, if you're adding, if you have a subtraction problem, if you have a multiplication problem, or if you have a division problem. Each one is solved differently, okay?